which has a longer displacement. A person who is walking on the street for 240 meters with different left turns and right turns, or a person who walks straight on a soccer field for 240 meters. We already discussed the difference between distance and displacement last meeting. So I think you already know the answer that a longer distance doesn't mean a longer displacement. This is Sir Siren, and today we will conduct experiment on vectors using forces acted at a common point in an object, which is the force table. So better prepare your writing materials to jot down all the important data on our experiment. So what are the materials we needed? First is, we have the force table, strings or cords. We also need a set of pulleys, the weight metals, weight hammers, and lastly, spring balance. So are you all ready for today's experiment? Have you prepared your writing materials and worn your laboratory gown? So if you are all ready, then let's begin our experiment. But before we begin with our experiment, first we have to create a table of values with 3 columns and 7 rows on it. On your column sections, write down force, the magnitude, and the direction. And on the row section, write down F1, F2, F3, equilibrium, resultant analytical, and the percent error. Okay, for the procedure of our experiment, first, secure the values and directions of your forces, which is your force 1, your force 2, and your force 3. Then record the forces and direction on the table of values you created earlier. On today's experiment, we will be using the force due to the gravity of the weight metal as our forces, which is also equal to the weight of these weight metals. So before recording the forces, make sure to compute the weight, and since we are dealing with the forces, therefore, we will use Newton as our standard or our SI unit for forces. Next is to attach the given weight metals on our weight hangers. Then attach it to the strings on our force table. Repeat the steps until you attach the 3 forces. Make sure that the direction is maintained using a pulley. So after you attach the 3 weights to the string, as you can observe, the ring of our force table is not totally balanced. And so, it is time to balance the ring of our force table. So by trial and error, using a spring balance, attach your spring balance to this fourth string. of your force table to be able to find the equilibrium of your force table. Pull and move the string of the spring balance and make sure that the pin of the force table will be at the center of your ring. Record the magnitude and the direction of your fourth string. And after recording the equilibrium of your force table, next is to identify the analytical resultant of your given data. Compute the resultant of your F1, F2, and F3 using the analytical method which has been discussed last meeting. Compare the value of the equilibrium and the computed resultant. So what have you observed on their values? Are they the same values or are they different? So how many percent is their difference? To compute the percentage of their difference, we will use the percent error. Using the formula of percent error, compute using the equilibrium as your experimental value and the computed resultant as the theoretical value. So you have 5. So how many percent is the computed percent error based on our experiment? Do you think our experiment is reliable? And that concludes our experiment for today. I hope you enjoyed our experiment and learned something new of it. Remember to keep your recorded data gathered in today's experiment. And lastly, wait for your teacher's advice for the gathering of your answers for today's experiment and for additional assessment. So see you again next time and goodbye.